here we have two distributions side by side. Over on the left, I have raw scores. So this is my raw scores, or you could just call this the original distribution. On the right, what I have is a set of z-scores that were determined using the z-score formula. So I took each one of these raw scores and I converted them to z, and because I did this for the entire distribution, what I have is my not only my z-scores, but I have the standardized distribution. What I want you to see is how these look back to back when I graph them both. So here we've got both distributions in a table. I want you to see both distributions on a graph to show you what happens with the shape of a distribution when you standardize it. So to do that, I'm going to need, let's see, I'll graph my raw scores first. My raw scores cover a range from 2 up to 14, so I'm going to need an axis where I've got room for 14 different scores. And then on the side, I really just need to have frequencies. Well, actually, let's do this first. I need to have 14 scores here, so let's try to do this evenly. So I'll call that, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so it's not perfect, but it's good enough for showing you what happens here. And then on the side, I just have to have room for a couple of frequencies. So this is going to be 1 and 2. So these will be my frequencies, 1 and 2. Down here, I've got my scores. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So going through my scores, I have, let's see, there is a 2. I have a single 2, so that's going to be there. And there's no 3s. The next thing that I encounter are my 6s, so I have 2 of those. Okay, so that'll be about here. And then I have an 8. And there's a 12 and a 14. Okay, so this is my original distribution. These are my raw scores. So you can see what the general shape is here, and now we can compare that to our standardized scores. So to do that, I really want to have these back to back. I'm going to create, well, essentially I'm just going to make a copy of the same set of axes. So let me take a moment here and do that. Okay, so I've finished setting up the axes. What I haven't done though is I haven't labeled my x-axis. I wanted to show you what I'm going to do there. Now, the frequency axis was simple. The most that I have of any z-score is just 2 of them. There are 2 negative 0.5s. But where am I going to put things on the x-axis? Well, a 2, my first raw score, goes with a negative 1.5. So it just makes sense to call this negative 1.5. And then I'm going to keep my scale going in the same way. Now the scale, I can work this out, what each one of these steps are, but I've got a z-score that goes with 6 of negative 0.5. And so between here and here, there are, let's see, 1, 2, 3, 4 steps. And so that's going to mean that this is a quarter each time. So this is going to be like negative 1.2 0.25, and this would be -1. I don't have a lot of space here. This would be -0.75. I don't really have to fill all these in though. It's going to get kind of cramped. I think it just makes sense to fill in where we actually have some scores. So for example, the 6 goes with -0.5. 8 goes with a score of 0. But you can see that this is 2 steps over. It's -0.5, -2.5, 0, because that is another quarter step. That's what's happening on this axis down here. Over here at 12, this would be 1.0, and 14 is going to be 1.25, 1.5. And if I go through and I plot each one of these, you'll see that what we get is the very same picture. We have one -1.5, so that's taken care of. We have 2 -0.5s, so that goes up to a frequency of 2. And then finally we have a 1. We've got our 0. We've got a 1 and a -1.5. A little sloppy there, but you get the idea. When I go from plotting my raw scores to my z-scores, nothing changes whatsoever with regards to the shape of the distribution. The distribution has the same shape. It's also spread out in the same way. So I have an exact copy. I've basically just remapped it onto different scores. Instead of having the original 2, 6, 8, 12, and 14, I've now got my z-scores, but nothing else changes. So when you change from a raw score, or when you convert from your scores from the original distribution into a standardized distribution, the shape stays the same.